On to question 3, which is about normal distribution. So the weights of women boxers in a tournament are normally distributed with a mean of 64. Oops, 64 and a standard deviation of 8. So we're talking about weight. So let's say W is normally distributed with a mean of 64 and a standard deviation of 8. That's how you write this down. Okay. The part A. Find the probability that a randomly chosen woman boxer in the tournament weighs less than 51 kilograms. So the probability that the weight is less than 51 kilograms. So first we have to standardize this. So subtract it from the mean divided by the standard deviation. The formula is x minus mu divided by the sigma. That is how you standardize a that's how you do the standardization. That's how you standardize. I think what's going on with me. Anyways, we have standardized it. Now we're gonna just carry out the simple maths. 651 gives us minus 1.625. So the minus, we can just flip the sign, 1.625, and then we'd have to subtract 1 from it, z 1.625, because this is how your normal distribution graph would look like. Terribly drawn. We're looking for the probability that z is greater than that is over here. So we're going to look for this side. So it's going to be 1 minus that. Remember, the area under the bell curve is 1. So we're going to go to our beautiful Pearson's formula booklet. And we're going to look for, what was the value? 1.625. So that's actually 1.63. So we're looking for 1.63. Where is 1.63? Over here somewhere. 1.63. There you go. 1.63. So it's 0.9484. 9484. 1 minus 0.9484. So 0.9484. Take away that. And you get a value of 0.0516. So 3SF it would be 0.052, I believe. 2. Yep. There you go. That is your answer to part A. Part B. In the tournament, women boxers who weigh less than 51 are classified as lightweight. Okay, so we gotta do some. Oops, we gotta do some. We're gonna become a little technical over here. So I'm gonna draw the bell curve. The curve is gonna save us here. So this is our bell curve. Holy God, became a quadratic. There you go. So our mean is 64. Now, they said people who weigh less than 51. So 51 is gonna be somewhere over here. That is my 51. And people who weigh less, so it's gonna be in this side, like this side over here, right? Are classified as lightweight. So right over here, they're classified as lightweight. Well, that's good. Ren weighs 49 kilograms, and she has a match against another randomly selected lightweight woman boxer. So Ren here weighs less than even 51. So Ren is 49. Is it 49? Yep. So Ren weighs 49. Now this is a given condition, I believe. So given that the person who he's going to fight against is less than 51, find the probability that Ren weighs less than the other boxer. So basically, this is a given condition, quite sneaky actually. So basically, it is saying that Ren is going to fight against someone who is guaranteed they're going to be less than 51. And the probability that Ren is going to weigh less than the other boxer, right? So we can just let's draw this out. So the probability that what ran what we can do is we know for a fact that the probability it's going to go under is that it's going to be less than 51. That is without a doubt. And given is less than 51, and Ren weighs less than the other boxer. Ren weighs less than the other boxer. So we know the probability that what was this again? Weighs less than 51. So we know the probability that somebody weighs less than 51. Okay. And so Ren has to weigh, let's say that the weight is less than 51, and Ren has to be greater than 4. Let's see if this works. So now we would have to standardize this. Let's say 49 minus 64. What was our standard deviation? It was 8. That becomes Z, 51 minus 64. And this becomes, we just did this, minus 1.625. And this becomes 49 minus 64 and 8 minus 1.875 probability. So we can say probability that Z is less than negative 1.625 minus probability that Z is less than 1.875. How much mark is this? 4 marks. So it's going to be a little bit lengthy. This is going to be probably less than, Z is less than 1.625 minus probability 1 minus probability Z is less than 1.785. So we can simplify this a little bit. There you go. Minus 1 plus probability Z is less than 1.875. The ones cancel out. And we need to find the probability that is 1.88. So let's go over here. We're looking for probably 1.88, 0.9699, 0.9699. We have to look for the probability. This is minus, isn't it? So we're looking for the probability that is less than, we did find this, right? This was a probability. So we're going to say 0.9484, and that is a subtraction. What does this give us? 0.9484 plus 0.9699. 0.215, and that's going to be divided. 0.215 is going to be divided by our 0.52, which was the condition that it is less than 51, so 0.052. And gives us a value of 0.41 0.415 something. So 0.42 would be our answer to this question. That was a weird question. In the tournament, women boxers who weigh more than H are classified as heavyweight. So I'm gonna draw this out again, or we're just gonna copy this and take this to, oopsie, that didn't work. Let's copy this and paste it over here. So the question says that H are classified as heavyweight. So let's say H is somewhere over here. Okay? And it says that given that 10% of the women boxers in the tournament are classified as heavyweight. So you need to have more than this. So this area over here is 10%. So the probability that weight is greater than H is equal to 10%. Probability weight is, it's going to standardize it, greater than H minus 64 divided by 8 is equal to 10%. Now 10% is a very what do you call it? It's a percentage given. Now let's look at the little table over here, and we do have 10% over here. That is the table we're going to be using. And remember, this is a condition where it has to be a greater sign over here. So what does this give us? Let's see, 1.2816. So we can say that h minus 64 is equal to 1.2 what? 816. 816. So h is equal to 64 plus 8 times 1.2816. 64 plus 8 times 1.2816. And this gives us a value of 74.2528 dot dot dot. So h is equal to 74.3 kilograms, was it? What was the kilograms? Kilograms to 3SF. There you go. So basically, we took they said it's you need to have a minimum of H to be even qualified as heavyweight, heavyweight, and 10% are heavyweight. That means 10% of the graph of the curve to the right is this area. So we just took this, and remember, you have to have a greater sign in order to use that little chart in your formula booklet. And that concludes question 3.